Hello mathematicians, welcome to our new topic, graphs and inequations, and we'll start off with inequations and inequalities. Now to begin with, you'll remember how we solve a linear inequality. We've seen that if we divide or multiply by a negative number, then we have to change the direction of the inequality. Likewise, although it's not mentioned here, if we take the reciprocal of both sides, we have to change the inequality. But also, you might remember that if we simply change the order of the inequality, as in something like this, if we have 3 less than or equal to x, and we swap the sides, then we have to change the inequality. And it's logical. If 3 is less than or equal to x, then obviously x is greater than or equal to 3. However, if we're solving a quadratic inequality, the easiest method of doing this involves sketching the parabola. So we'll have a look at these two examples and see how this pans out. So for our first inequality here, x squared less than or equal to 4. Now you might be tempted to take the square root of both sides and you get x less than or equal to plus and minus 2, which doesn't make a lot of sense as written. So it's more useful if we rewrite this and bring our 4 across, make it x squared minus 4 less than or equal to 0. Then we factorise, well, we could factorise this. Well, we can see it's a difference of squares, x minus 2, x plus 2, less than or equal to 0. And we do that so that we can sketch the parabola. So we know that this is a parabola which is concave up, which is cutting through at minus 4 on the y-axis, and it cuts at plus 2 and minus 2 on the x-axis. Plus 2, minus 2. Now think about what this parabola actually is. This parabola is indicating the y values for different x values. But what are the y values? Well, because this is the parabola, y equals x squared minus 4, those y values are values of x squared minus 4. So where are those y values less than or equal to 0? They're less than or equal to 0 in this part that I will shade red. So they're equal to 0 at minus 2 and plus 2, and they're less than 0, in other words they're negative, for this part of the curve. Now we're not interested in the actual y values, apart from the fact that we want them to be negative. What we're interested in are the x values that cause our curve to be negative. So our solution then is that any x values between minus 2 and plus 2 will give us negative values of x squared minus 4, or negative or equal to 0. So this is our answer, that x squared is less than or equal to 4 when negative 2 is less than or equal to x less than or equal to 2. Okay, so let's have a look at our next example. X squared minus 5x less than 6. So if we rearrange this so it's a parabola, x squared minus 5x minus 6 less than 0, and we factorise our parabola, so treating this as if it's equal to 0. So two numbers that multiply to minus 6 and add to minus 5 would be this. So the critical values here are x equals 3 and x equals 2. And we know that they're the values which, if we sketched up the parabola y equals x squared minus 5x minus 6, they would be the values where we cut the axis at 2 and 3. Now we're not really doing a sketch of the parabola for the sake of a sketch of the parabola. So we don't care about the y-intercept. We just want to know where we cut the axis and the concavity, so that we can then focus our attention on this inequality. So where is this thing, x minus 3 times x minus 2, less than 0? Well, the same as the one that we just did. It's going to be for values of x between 2 and 3. But this time, because it's a less than, it's not going to include the values 2 and 3. It's like we have open circles here, and it's just this part here. So that will be when negative 2 is less than x, when positive 2 is less than x is less than 3. The next type of inequality that we might encounter in extension 1 is an inequality which is fractional and which has an unknown in the denominator. And when we look at these, we need to bear two things in mind. The first is we need to be aware of any restrictions on the domain. So we know we're not allowed to divide by 0. The second is the fact that if the denominator were to be a negative and we had to multiply it across the inequality, we know that the inequality would need to be reversed. So the way that we overcome this latter problem is by actually multiplying both sides of the inequality by the square of the denominator and then solving that. So we'll look at an example and hopefully this will become a little bit more apparent. So if we look at this example here, we can see that we're not allowed to have x equals 4 because we'd be dividing by 0. And this x minus 4, depending on the value of x, could be a positive or a negative number. So if it was a positive and we multiplied it across, no worries, the inequality stays the same. But if the value of x made the bottom a negative and we multiplied it across, the inequality would have to change. Now we've got a couple of options. One is that we could look at both of those cases and somehow try to combine them. The easiest method though is to say, well, I'll take the 2x minus 4 and the 8 and I will multiply both sides by the same thing, something that doesn't change it. And the thing that I'm going to multiply it by is x minus 4 all squared. So you might wonder why we would do that. And the reason is simply that if I multiply by the square, I know that that's going to be a positive quantity. Anything squared has to be positive. So by multiplying both sides by a square, that means I'm multiplying both sides by a positive. So I don't have to worry about the inequality. Now when I do that, then this is going to go out with one of those to leave 2 outside of x minus 4. Over here I've got 8 outside of x minus 4 all squared, which we know is square of the first minus twice their product plus the square of the second. And I no longer have a fraction. So when I don't have a fraction, I haven't got that concern about whether the denominator is positive or negative. Now I just gather terms together. So if I just expand these brackets out, 2x minus 8 less than or equal to 8x squared minus 64x plus, what's that, 128. And if I just take this 8 over and add it, that will now be 8x squared, and this will become 136. And I'll take these 2x over and subtract them. So that will be minus 64x minus another 2, so it's minus 66x. And I'll have 0 here. Now, if I then rewrite that to make it a little bit simpler, I could just test whether there's a common factor that I can divide into these. And there's not much except 2, I think. So I could make it, if I divided everything by 2, I could have 4x squared minus 33x plus, what's that, 24. But also, I'll shift it across to the left-hand side. So this is like one of the first points that we made up above. So I'm going to take all of this over to the other side, and while I'm doing it, I'll divide by 2. So that will give me 4x squared minus 33x plus, what do we say, 68 is greater than or equal to 0. So if I then continue on, form up my quadratic and factorise it, and I couldn't think of two numbers that equaled 4 times 68 and added to minus 33, so I went with the quadratic formula just as well because there weren't nice numbers, so they were 4.5 and 4. The main thing is that I now have my parabola, which is cutting at 4 and 4.5. That's all I really need to know. And I want where that parabola is greater than or equal to 0. So that is up here and up here. Now I include the 4.5, but I can't include the 4 because we're not allowed to have x equal to 4. So my solution to this quadratic inequality is is x less than 4, so that's all these values this side, and x greater than or equal to 4.5. Now for our next example here, we can see that we're not allowed to have x equal to 1. And if I follow our process, we've got x plus 1 on x minus 1 times x minus 1 all squared less than 2 times x minus 1 all squared. So this goes out with that one. We've got x plus 1 times x minus 1. We know that's a difference of squares. And we want that to be less than, over the other side, when we expand the square, it'll be x squared, so square of the first, minus twice their product, so that's 2x, and multiplied by that 2 is 4x, and then plus 1 squared, so that's 2. So if I gather stuff together, again I'll bring this x squared over to here, so I've got x squared, I've got to subtract it, I've got minus 4x, and when I bring that over to here, I've got plus 3. And then I'll rearrange that, so I've got x squared minus 4x plus 3 to be greater than 0. So are there two numbers that multiply to plus 3 and add to minus 4? Yep, there are. So x minus 3, x minus 1 greater than 0. And we can see we've got the parabola cutting at 1 and 3. We want where that parabola is greater than 0, which is here and here, but because it's not an equality, we've got an open circle there. So our answer is that we want x to be less than 1, x to be greater than 3. So have a go now at these in 3A.